I'm going to start by working these through just kind of straight up. And that is, I'm just going to start by doing the multiplication. So I'm going to multiply straight across the top and straight across the bottom. Now, some of you on our most recent quiz ran into trouble on a similar problem to this one, because the very first thing you did is you multiplied everything out, and you would have ended up with something like x to the power of 4 and this big, long, ugly thing. You don't need to do that, though. In fact, if you do that, you're going to make your life way harder than it should be, and end up with something that doesn't look like we can actually simplify. The best way when it's factored is to leave it factored. And multiplying them, just multiplying straight across the top, straight across the bottom, it just basically turns it into one big, long multiplication chain. All right, and so now that we've multiplied it all out, now I look to see what is multiplied into both top and bottom that I can cancel. So like, I see x minus 3 on the top. I don't see 1 on the bottom to go with it. I see x minus 7 on the top and on the bottom, so I can cancel those. The x minus 1, yes, it has a partner on the bottom, so I can cancel that out. The x minus 8, it has a partner on the bottom, so yes, I can cancel it out. After doing all that, we end up with just x plus 3 left on the top, and just an x plus 4 left on the bottom. And that was it. 3 of the sets of parentheses actually ended up canceling out. Now, that won't always be the case. Sometimes might be none of them canceling out, or just 1 pair or 2 pair or whatever. But you can see that when this happens, we end up with something certainly a lot simpler, just x plus 3 over x plus 4. Now, I mentioned, though, that there were a couple different methods people used. A couple of you looked at this and you said, can I just cancel out this whole x minus 1 and x minus 8 at the start? Technically, yes, you can do that. And if you see that, you can go ahead and do that, and you can use that to your advantage. But remember, we can only do that because it's multiplication. Things could potentially, at least, be a little bit trickier when we do division. And so that's what we want to take a look at next. Go ahead and write down this problem now, and then we'll work it through and see how it gets addressed. So the first step in any kind of fraction division problem is multiply by the reciprocal. So, flip the second fraction and at the same time change the division into multiplication. And so that's all I've done here, is all I did was just flip and multiply. And then, of course, if I'm going ahead and just doing this straight up, because yes, there's some reducing we can do, which we'll talk about in a minute, but if we're just going to do it straight up, which will always work, you just multiply everything into just one big fraction, with all the parentheses still left as parentheses. Remember, you do not want to have to multiply these out, not only because it's a lot harder, but also because if this was all written in expanded form, we wouldn't be able to see what can cancel. It doesn't leap out that way. It only leaps out when it's already factored like this. And now at this point, all we got to do is just look for stuff that's in the top and the bottom of our fraction that we can cancel out. I see I can cancel out a pair of x minus 6s. I have a pair of x plus 2s. And I have a pair of x plus 4s. Which means that on the top I'm left with x minus 5. And on the bottom I'm left with x plus 3. And that's it. And yes, that's my final answer. That's as much as I can do on it. I can't reduce it anymore. Notice I only have x's in 2 of the terms, not in all 4 of the terms. So no, it doesn't reduce or simplify it all past that. So that's our final answer. Now, going back to the question of, can you simplify it at the start to make your life a little easier? Yes, you could have actually done something at the start of this one. But be careful with division. Because let's say that this was the same as this. You cannot cancel those out when you're doing division. Because you'll notice that we end up flipping this fraction. And so the top becomes the bottom and the bottom becomes the top. Meaning that what once was in both the top and the bottom would become the top and the top. And we couldn't cancel that out. So be very careful if you're trying to reduce it at the start. Only do that if you feel really secure with it. Now, the one thing that I see that you might have actually been able to do and felt pretty confident about at the start in terms of reducing is in this first fraction, I see an x plus 2 in both top and bottom. And since it's in both the top and the bottom of the same fraction, yeah, you could have actually canceled those out at the start there. And that just means that you would have canceled that part out a little bit earlier, but notice we ended up canceling it out later anyway. So if you don't cancel at the start, it doesn't hurt you any. You can always just do the flip and multiply, make it all into one fraction, and then reduce from there. The other type we're going to be taking a look at today is multiplying by rational expressions that involve binomials. So go ahead and write down this problem and we'll take a look at how we would do it. So in order to do this one, notice it's a multiplication problem. So I'm going to go ahead and start by just multiplying these through. Now, in terms of multiplying it through, it might look a little bit weird to your eye in terms of seeing how to do that. Basically what I'm doing is I'm multiplying this 5x to the 7th, and I'm distributing it into the binomial. And so I'm going to be multiplying it into the 4 and into the 12 terms. Okay, so let's go ahead and do that. So 5 times 4 gives me 20. Then I do the x to the 7th times x to the 6th there as well. So that gives me x to the 13th. The minus stays a minus. Now I do the 5 times 12, which is 60. And then x to the 7th times x to the 5th will give me x to the 12th. Okay, that's just doing the multiplication on the top. Now I need to do the same kind of thing on the bottom. And just like we did with the top, I'm basically distributing that 6x squared into both of these terms over here. So that means first doing 6 times 20, which is 120. Then the x squared times x to the 8th is x to the 10th. The plus stays a plus. 6 times 15 gives me 90. X squared times x to the 7th is x to the 9th. And so for each case, I distributed just like if I had the number with the x and all that kind of stuff outside the parentheses, I distributed it into the parentheses. All right. So now that we've done that much, now I can take this result and simplify it. So let's go ahead and take it piece by piece. Looking at this fraction here, I'm just going to start by looking at the numbers. 20, 60, 120, and 90. What can I divide all those by?
30. 30.
Let's see here. I can divide by 2, but there's something bigger. 30 I can't take out of the 20, so 30 is too much.
20.
20, I can't take 20 out of 90, so yes, it must just be the 10.
I just saw all that.
All right, so then, I'm going to start by doing just that. So, all I'm doing right now is dividing every term by 10. Now I did that just so I could focus on the numbers, because if I'm trying to remember what number am I pulling out and how many x's am I pulling out at the same time, it tends to lead to stuff getting mixed up. So I just do the numbers first. Now that I've done that, I can look at my x's. So I have x to the 13th, 12th, 10th, and 9th. How many x's can I pull out of every term then?
9.
9. Yep, because that's the fewest number of x's that I have in any given term. So I'm going to pull out x to the 9th from every term now. So if I take x to the 13th divided by x to the 9th, that's like subtracting the exponents. So 13 minus 9 gives me x to the 4th. And we do the same thing for the rest as well. So the x to the 12th becomes x to the 3rd. X to the 10th becomes x to the 1, which is just x. And the x to the 9th, it totally cancels out so that there is no x left in this term. So that is it. That is my final answer. 2x to the 4th minus 6x cubed, all over 12x plus 9. All right, so as you take a look at this problem, it certainly looks like it might be a little bit tougher, and it actually is. This one's much more involved because we have binomials in both the top and the bottom of both of these fractions. So, what do? Well, we start it the same way. This is one of those cases where if you just trust your process, it'll get you there in the end. It's just that the process, it just takes a little longer to do. All right, so first thing, I'm going to do the flip and multiply because I notice this is division. So the first fraction, it always stays the same. But the second fraction, that's the one that's going to change. Because remember, I'm going to take that division and change it into multiplication. And at that same time, I flip the second fraction. All right, so having done that, we now can go ahead and worry about multiplying them through. Now on the top, that means I actually have to do this 5x to the 7th plus 20x to the 6th times 6x minus 42. And we have to multiply everything in the first parentheses by everything in the second parentheses. So, go ahead and do that. You might need your calculator at a certain point, and that's okay. Go ahead and multiply those through. Now when you multiply all that through on the top, this is what you end up with. Repeat the process on the bottom. Multiply everything in the first binomial by everything in the second binomial. Right, and then when we repeat the process on the bottom, this is what you should be looking at. Now, you'll notice that there is actually some like terms that we can combine on top and bottom. Now, we're going to have to be looking for a way to reduce this whole thing, so let's go ahead and do that. Combine the like terms, because it's going to mean there's less stuff that we got to look at when simplifying this whole thing. All right, so after you combine the like terms, this is what you're looking at. Now, just like we did with the last one where we had a binomial over a binomial, we need to look at our trinomial over trinomial and see what can I divide out of every single term. It's just in this case there's a total of 6 terms that I'm looking at. Okay, but again, I start by looking at the numbers. 30, 90, 840, 10, 30, 280. What can I divide them all by?
10.
10. Yep, made it nice and straightforward. We can just factor out a 10 here. So I'm going to put in the numbers first. So that's going to become a 3, minus a 9, minus an 84. Remember, I'm coming back to fill in the x's in a minute. Then on the bottom, the 10 is just going to become a 1. So I want to put a 1 in there as a placeholder. Minus a 3, minus a 28. All right, now I'm going to look at the x's. How many x's can I pull out of every term? 5, yeah. Because that's the fewest number of x's I have in any of them. And so, my x to the 8th is going to become an x cubed, because 3 minus 5 is 3 there. Then the x to the 7th becomes x squared, and x to the 6th just becomes an x. Same thing on the bottom. 7 minus 5 gives me 2, so this is an x squared. Since I actually have one x squared, that means I don't need to keep the 1 there. I can just write it then as x squared. If I didn't have an x left, I'd still have to have the 1 there though. And then the x to the 6th is just going to become x, and x to the 5th that we had here, it's totally canceled out, so there's no x to be written there, which means that I'm now at my final answer. This is it. This is about as complicated as you're going to ever have to deal with right now. Now, for this problem, I could actually start it the exact same way that I started all the previous ones. I could go ahead and flip the second and multiply straight across and do all the same stuff. But just because I want to show you a way that you, at least at times, might want to make your life a little bit easier, I'm going to go through a slightly different process on this one. And that is going back to that idea of simplifying at the start. Take a look at each of these fractions. What I want to do is simplify each fraction before I even go and start doing the actual math behind it, of the multiplication, division, all that kind of stuff. So looking at just the first fraction, I'm looking at the numbers first, 18, 15, 21, and 30. You notice I can actually divide all of those numbers by the same thing. I can divide them all by 3. So I'm going to do that to that first. So I'm going to make that into a 6, a 5, a 7, and a 10. And then I'm going to look at the x's. And I see that x to the 6th is the smallest x that I have there. So I'm going to pull out x to the 6th from each, which makes this first one into x cubed. The x to the 6th totally disappears. X to the 7th becomes x, and x to the 8th becomes x squared. Now, I'm only doing one thing at a time, so I'm only doing the simplifying right now, so this is still a division problem. I'm not flipping and multiplying at the same time. Otherwise, we run the risk of forgetting something along the way or losing track of what was in top or bottom. And now I'm going to repeat that same process for this one. I'm going to reduce that.
7.
Yeah, notice I can divide top and bottom there by 7. So I'm going to make that into a 3 over 2. And then notice I can pull x cubed out of both top and bottom. And so I'm going to do that now. So the x cubed on the top goes away, and I'm left with x squared on the bottom. All right, now that I've done that, there's no more simplifying I can do, so I'm going to now go ahead and do the flip and multiply part. So that means I'm just rewriting the first fraction exactly as it was. But the second fraction, I'm going to go ahead and flip. So it becomes 2x squared over 3.
Where did the x?
Now at this point, we can now see why would we want to do that potentially at the start. Because if I did not simplify first, this line here would actually have me multiplying 14 times 18 and 15. And I'd be multiplying 21 by 21 and 30. I don't know those off the top of my head. I'd have to break out the calculator, I'd have to do a whole mess of work, and then you can imagine we'd end up with really big numbers to reduce. Well, now if I do that though, notice what I end up with. 6 times 2, that's easy, 12. And x to the 5th. Minus 5 times 2, that's easy, 10. X squared. Continuing, multiply on the bottom, all I'm doing is multiplying by 3. So that becomes 21x plus 30x squared. Now, our answer still reduces a little bit from here. So yeah, I got to end up reducing again. But notice that the math was a lot easier to get there. And it's now a lot easier to look at the numbers here and see what actually multiplies into them all. So looking at 12, 10, 21, and 30, what can I divide them all by? Actually, nothing. Because, for instance, what goes into both 10 and 21? Nothing. Because 10 is 2 and 5, 21 is 3 and 7. So imagine if we hadn't done all that simplifying first, you'd have a big ugly number and you'd be spending a while just punching numbers into your calculator. So by simplifying first, you made that process so much easier. So I still have a 12, 10, 21, and 30. And then for the x's, well, the smallest number I have in any given term is just this x right here. So I can just pull one x out of every term. And so each exponent just goes down by 1. And notice the 21x just becomes a 21. Therefore, we're done. That is as simplified as I can get. Now, did you have to simplify first? No. You can go ahead and multiply through at the very start. You're just going to have some big numbers to reduce. That's okay. You can do that. I just find it a little bit easier sometimes to do the simplifying first.